Welcome to this explainer. Today we are going to completely demystify the absolute miracle of physics that keeps these massive metal machines soaring safely through the clouds. We're going to break down some really fascinating concepts so we can finally grasp exactly what's happening up there in the sky.
Just picture this for a second. Every single day, over 100,000 flights take to the skies, carrying millions of people all across the globe. And some of these aircraft weigh a truly staggering 500 tons when they're fully loaded up with fuel, cargo, and passengers. To put that into perspective, that is the equivalent weight of over 100 elephants, all hurtling down an airport runway at lightning speed.
When you think about the sheer mass involved there, it almost feels completely impossible, right? A machine made mostly of heavy metals, carrying hundreds of people, just rises into the air and stays up there with incredible stability for hours on end. Which brings us to the ultimate question we're answering today. Why doesn't it simply fall? How does gravity not just pull it straight back down to the Earth?
Okay, here's our flight plan for this explainer. We'll be covering the miracle of flight, the 4 invisible forces, mastering the airfoil, surviving the unexpected, and decades of engineering innovation. We're going to break down the problem of gravity and the brilliant engineering solutions that make modern aviation possible. Let's dive in.
Section 1. The miracle of flight and the perfect balance required to achieve it. We really have to start by understanding that flight isn't about magic. It isn't about luck, and surprisingly, it isn't even just because of those massive jet engines you see strapped to the wings.
The real secret to keeping a 500-ton aircraft aloft is a continuous, incredibly delicate balance. We're talking about a perfect trinity of physics, aerodynamic design, and advanced technology. It is widely considered one of the greatest engineering achievements in human history, mostly because literally every single component on a modern airliner is specifically engineered to play its part in this exact balance.
Moving to Section 2, the 4 invisible forces. To truly grasp how this works, we have to look at the battle in the sky, the 4 invisible forces that are acting on every single aircraft from the exact moment it starts moving down the runway.
It's basically a massive, continuous tug of war. Vertically, you've got weight constantly pulling the airplane downward, which is fought by lift, pulling it right back up. Then horizontally, drag is trying to slow the plane down while thrust pushes it forward. For an airplane to fly safely, these 4 opposing forces must stay perfectly balanced. If even one force overpowers the others, the aircraft's behavior changes dramatically.
Now, here is a really crucial point. Thrust pushes forward. It does not hold the airplane up. This is such a huge misconception. Those massive jet engines you hear roaring on the runway, they are not pushing the plane up into the sky like a rocket. Their main job, really their only job in terms of these 4 forces, is just to push the aircraft forward through the air to overcome drag.
So that brings us to Section 3, mastering the airfoil and the actual science of lift. Because this raises a pretty fascinating question. If the engines are only pushing the airplane forward horizontally, how on earth do the wings create enough vertical lift to raise hundreds of tons into the sky? Well, the answer starts with the airfoil. That's a carefully engineered wing design featuring a curved top and a much flatter bottom to completely manipulate airflow. If you look really closely at the cross-section of a commercial wing, you'll realize its shape is far from ordinary. It is meticulously designed to slice through the sky in a very calculated, highly specific way. What's absolutely mind-blowing here is the pressure differential this shape creates. As the airplane moves forward, air gets forced to flow around the wing. Because of that curved top we just mentioned, the air pressure actually becomes lower above the wing. Meanwhile, the flatter bottom creates higher air pressure underneath. High pressure naturally wants to rush toward low pressure, and in doing so, it literally pushes the wing up. That pressure difference creates the vital upward force we know as lift.
But wait, there is even more physics at play here. Good old Newton's third law kicks in. Every action has an equal and opposite reaction. As the wing carves through the air, its shape and angle physically deflect the airflow downward. Because the wing pushes the air down, the air reacts by pushing the wing up. Combine that powerful reaction with the pressure difference we just talked about, and boom, you generate enough total lift to finally conquer gravity.
Let's look at how this builds in real time during a takeoff sequence. Step 1, the engines throttle up and the plane accelerates down the runway. Step 2, as speed increases, way more air flows over those airfoil wings. Step 3, at the exact split second the upward lift becomes greater than the downward weight of the plane, the aircraft gently, almost magically leaves the ground. It absolutely needs that forward speed from the engines to create the airflow over the wings to get that lift. On to Section 4, Surviving the Unexpected. Now that we know exactly how planes fly, it's time to bust some aviation myths and talk about what happens when things don't go as planned up there. Let's start with the absolute nightmare scenario for a lot of people: engine failure.
So many passengers have this fear that if the engines stop, the plane just drops straight down from the sky like a stone. But the engineering reality is completely different. If both engines stop, modern aircraft do not plummet. They actually act as highly efficient gliders. Thanks to their aerodynamic design, they move many kilometers forward for every single kilometer they descend. It's a gentle, forward glide that gives pilots incredibly valuable time to troubleshoot, restart the engines, or safely route to a nearby runway. Another incredibly common fear is turbulence. But in reality, turbulence is simply irregular air movement. When the airplane suddenly shakes and drops a bit, it is not in structural danger. It's just the aircraft encountering shifting air currents. Think of it exactly like a car driving over potholes or bumps on a dirt road. It might spill your coffee, sure, but the vehicle itself is perfectly fine.
And to handle that bumpy ride, wings are built to flex. They do not break. Commercial airplane wings are purposely built to act as highly flexible shock absorbers. Seriously, if you look out the window during turbulence and see the wing bouncing up and down, do not panic. That is the wing doing exactly what it's supposed to do, safely absorbing those changing air currents so the plane remains remarkably resilient.
Section 5, Decades of Engineering Innovation. This incredible structural resilience brings us to why this is the safest way to travel. The relentless, downright obsessive attention to engineering makes commercial aviation one of the absolute safest forms of transportation on planet Earth.
Safety is literally baked into every single component. Critical systems always have backups, and very often backups for the backups. Flight computers are constantly monitoring every variable. Pilots undergo years of intense training before carrying a single passenger. Aircraft undergo rigorous inspections throughout their entire service life. And before a plane is ever even approved, it goes through thousands of hours of extreme testing where wings are literally bent upward to impossible angles under massive loads just to prove they perform safely when the unexpected happens.
Ultimately, what we are looking at here is perfect harmony. Flight is the result of physics working in flawless synchronization. You've got powerful engines providing the thrust, perfectly designed airfoil wings generating the lift, and advanced computer systems and highly trained pilots maintaining the balance against drag and gravity.
I absolutely love this final thought. We are held in the sky not by magic, but by the elegant laws of science. So the next time you look out of a plane window at those breathtaking aerial views, remember, you are witnessing an engineering marvel. You are riding inside a 500-ton testament to human ingenuity, which really just leaves us to wonder, with the sky no longer the limit, what other seemingly impossible scientific feats will humanity conquer next?